Good evening, good morning, whatever it happens to be. So today we are going to be doing section 5.4, and this is actually the easiest of all the sections in chapter 5. So if you've gotten this far, relax. This is easier than 5.1 and 5.2. It is only one formula, and if you look on your pink sheet from New Jersey, you'll notice it's right down here in this corner, and it's called the sum and difference formulas. There are actually 6 formulas, and they're all very easy. You don't need to memorize it. You just need to be able to use it. What these formulas do is they allow you to take an angle, and they allow you to break it into 2 other angles to evaluate it. Let me just prove to you first that it works, and then you'll see why and where it might come in handy. So I gave you a little example here. First of all, here are the 6 formulas. These are 6 formulas. And I'm going to give you a numerical demonstration of this first one. So for example, the sine of angle A plus angle B equals the sine of A times the cosine of B plus the cosine of A times the sine of B. You'll see this in calculus on occasion, and so you just need to be able to work with it. Let me give you an example. For example, the sine of 90 degrees, and I hope you guys all realize this is 90 degrees because the sine of 30 plus 60 is the sine of 90, is 1. And that is going to equal the sine of 30, which is a half, times a cosine of 60, which is also a half, plus the cosine of 30, which is root 3 over 2, times the sine of 60, which is also root 3 over 2. So what you should have here is 1 equals 1/4 plus root 3 times root 3 is 3, and 2 times 2 is 4. And as you can see, it does work. 1 equals 1/4 plus 3/4. So where might this be useful? Let me do an example with you here. Let's find the exact value, not approximate, of the sine of pi over 12. So if you look on your unit circle, do you see pi over 12? No, you don't. However, do you see values whose difference or sum might be pi over 12? Yes, you do. Maybe you don't see it yet, so let's turn this to degrees. Let's make pi over 12 degrees. So pi over 12 radians. To turn it into degrees, I'll multiply by 180 over pi. Those cross out. I get 180 divided by 12, which is 15 degrees. So basically, I'm asking you to find an exact value for the sine of 15 degrees. Okay. Do you see any values on unit circle whose difference is 15? There are lots of them. But let's do this one. Let's write the sine of 15 as the sine of 45 minus 30. Now, because it's sine and there's a minus, I'm going to use the second one, sine minus. And I'm going to rewrite it this way. In my particular case, A is 45 and B is 30. So let's go ahead and write this. So this is going to equal the sine of the first angle, which is 45, times the cosine of the second angle, which is 30, minus the cosine of the first angle, times the sine of the second angle. All right, let's see what we get. The sine of 45 is root 2 over 2, and I know that because it's on the unit circle. The cosine of 30 is root 3 over 2. The cosine of 45 is root 2 over 2, and the sine of 30 is 1/2. So the exact value is going to be root 6 over 4 minus root 2 over 4. Or, written together, root 6 minus root 2 over 4. And that is the exact value of the sine of 15 degrees. If you put this into a calculator, you'll find out it's approximately 0.26, which should make sense because remember that the sine is the height on a unit circle. So at 15 degrees, the height is only about 0.26. All right, I think you can actually do example 2 by yourself because I'm going to ask you to do the same thing, except it's going to be a different angle this time. It is going to be the cosine of 75. Can you think of 2 numbers that are on the unit circle that have a sum of 75? Go ahead, you try it and make sure you use the right formula. Here's what you should have done. You should have said to yourself, I think the cosine of 75, ooh, that's too big, could be rewritten as the cosine of 30 plus 45. And because it's a cosine, I'm going to have to use a cosine formula. So using a cosine formula, it's going to look like this. It's going to be the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Hope that's what you got. So now let's just go ahead and write our exact values. That's root 2 over 2. That's root 3 over 2. That's root 2 over 2. That's 1/2. So the exact value is root 6 over 4 minus root 2 over 4, or root 6 minus root 2 over 4. Wait a minute. That looks very familiar. That's also 0.26-ish. Oh, let's see. Do you guys remember that the cosine of 75 and the sine of 15 should in fact be the same? Because they are complementary angles, and that's why it's called the cosine. So anyways, yeah, the sine of 15, the first example, and the cosine of 75, the second example, have to have the same answer. Although we use different formulas to actually get there. All right, hopefully that's easy. Let's do one more. Let's find the tangent of 105. So let's look on a unit circle and think of two numbers whose sum is 105 or difference is 105. I'm going to use a sum. So the tangent of, let's go 60 plus 45. So now we're going to have to use one of those tangent formulas. Now they look kind of nasty. They're a little bit harder to do. But if you look at the tangent formulas, you'll see that this is going to equal the tangent of 60 plus the tangent of 45 divided by 1 minus the tangent of 60 times the tangent of 45. Okay. So now let's go ahead and find these exact values. So some of these are easy. Like the tangent of 45, we should know that it's 1. That one is one that you should memorize. However, the tangent of 60 is a little bit tougher. Now, don't forget that the tangent is very simply the sine over the cosine. So the sine divided by the cosine. So at 60 degrees, the sine is root 3 over 2, and the cosine is 1/2. And therefore, the tangent at 60 degrees is simply going to be root 3. You can memorize that one too if you want. So that's going to be a root 3, and that's going to be a root 3. So my exact value of the tangent is actually going to be this ugly expression, root 3 plus 1 over 1 minus root 3. This is the exact value. Now, you could put that in a calculator and you can get a decimal, but the exact value is just that. Example 4. These are for homework questions 29 and 31. These are very, very, very quick. It says simplify this expression. So this time we're doing it backwards. It has it already expanded, and you have to go find what the original angle would have been. So look at your 6 formulas that I gave you in the notes there. And, well, what's it look like? I have a sine times a cosine, and I have a plus. That looks like the first one, isn't it? So this is very simply going to be the sine of x plus 2x, or simply the sine of 3x. Just going backwards on that. Pretty easy to do. Okay, let's go to the next page. Here are the last 2 examples. This one is example 5, and it's the same thing that we just did. So, I don't know. I guess you could give it a go. I pause and you try it. So here's what you should have done. I've got cosine, and a minus. So looking at my formulas here, I can tell that that must be one of the cosine formulas. And because there's a minus here in the middle, I know that these angles need to be added. So that's going to be the cosine of pi over 16 plus 3 pi over 16, or the cosine of 4 pi over 16, which is really the cosine of pi over 4. Now, this one says to find the exact value of the expression. So I'm going to take it one step further. At pi over 4, the value of the cosine is root 2 over 2. And I can just get that from the unit circle too. Pretty easy. There are a lot harder questions in this chapter, but I am very merciful. And I know this is harder to do online, and therefore I've really stripped it down. Just need to be able to use the formula and recognize it when you see it. Example 6. Verify that this cofunction identity is true. If you look on your sheet, you will see somewhere it says cofunction identities, right there. And this is one of those identities. We're going to verify or prove that it's true. And we're going to do that using basically this sum and difference formula. So I have a cosine and this angle minus this angle. So that is going to equal, using the cosine formula, it's going to equal the cosine of the first angle, times the cosine of the second angle. And then because I have a minus here, with the cosine formula, I'm going to use a plus the sine of the first angle times the sine of the second angle. Well, let's see if it works. The cosine of pi over 2 is, look at your unit circle, it's 0. The cosine of x, I don't know what that is, but that's a cosine of x. The sine of pi over 2 is 1. That's an ugly 1, sorry. And the sine of x is just a sine of x. So that obviously is 0, and 1 times the sine of x equals the sine of x. Therefore, this equals the sine of x. Let's see if I can write that in black over here. Equals, oh no, I can't write off the paper. But yeah, this equals the sine of x. And we have proved what we wanted to prove. QED and chicken. So I hope this one's easy for you. If you have questions, please do ask. You can email me. I am only one email away. I check my email every day. So see you next week. Best of luck to you. Remember, 80% accuracy. See ya. Oops, I forgot a little something. Did you guys happen to notice that when I gave the answer for the tangent as root 3 plus 1 over 1 minus root 3, I forgot to rationalize the denominator. So actually, you should keep on going from here. I think if you put that in the book, it's not going to like it. So we're going to have to rationalize by multiplying top and bottom by the conjugate. And this is, got to distribute here. So that's root 3. That's root 9, which is 3. That's 1. And that is also root 3. Divided by, that's 1. That's root 3. That's negative root 3. And that's negative root 9, which of course is just negative 3. These guys cross out, and therefore my final answer is 2 root 3s plus 4 divided by negative 2. Because both of these terms are divisible by 2, I can go one step further, divide by negative 2, and get negative root 3 minus 2. And that is the actual answer that the book will actually like. It's kind of crazy that this expression is the same as this expression. But put them in a calculator, you see, they're about the same. They're approximately negative 3.8-ish each, more or less. All right, now you can do your work. Have a good time. Bye.